Hey guys, today we're going to be starting balancing chemical equations. Now, chemical equations are pretty cool. They are the process by which compounds are formed or rearranged to make new compounds or broken apart into their specific elements. Basically, anytime there's a chemical change happening, it's because of a chemical reaction. And the way we represent chemical reactions are through chemical equations. Now, before we can get into all the good stuff like balancing, you got to know exactly what a chemical equation looks like. And before we get going too far, these notes are found on slides, I think, 6 and 7 of your digital notebook. So whip that out and follow along there. There'll be some places you can type in some numbers, add in some coefficients, all sorts of fun stuff. So whip that out and follow along there with this video. First up, we have to know what a chemical equation looks like. And a chemical equation looks kind of like a math equation. You'll have something plus something on one side. These are called the reactants. They're the things that are reacting that you start with. Then you've got this cool arrow. The cool arrow means yields. When we say these things out loud, we say yields. That's kind of like the equal sign in math. One side of the chemical equation is going to equal the other side of the chemical equation, but it's an arrow here, full arrow, because we're indicating the direction that we're going. So we start at the back end of the arrow with the reactants, and we end up, we're going towards the other side, which is going to be the products side. Product side over here, I'll highlight in green. So this is what a chemical equation looks like. You've got some reactants, an arrow, and some products. You could have one reactant, you could have two reactants, you can have any number of reactants, any number of products. But you start with the reactants on the left-hand side, and you yield with the arrow the products on the right-hand side. So balancing chemical equations comes in because of a thing called the conservation of mass. The conservation of mass says that the amount of matter you start with is the amount of matter you end with. So the exact atoms you start with has to be the exact atoms you end with. And there are rules for figuring out how this works. We're going to look at this example down here, and you can follow it on your notes in your slides. This one down here, I'm going to walk you through all of the steps for how you do it. This H2 plus O2 yields H2O. So rule number 1 for balancing is that you have to have the same number of atoms of all elements on both sides. Let's look at this equation right now down here. Looking at hydrogen, you've got 2 hydrogens on the left-hand side, which is the reactants, and 2 hydrogens on the right-hand side. All good. We have the same number on both sides. But if you look at O2, you've got 2 in the reactants and just 1 in the products. That doesn't line up. We lost an oxygen along the way, which is not allowed. So we have to figure out how to balance this out to have the same number on each side. I'm going to show you right now exactly how to do that. And actually, this is all written out in your notes. I'm going to cover that up so that I can just write it out instead of following along with the typed words. All right, so we've got H2O2, and that's yielding H2O. We've got hydrogen gas, oxygen gas. Those are both with a 2 because they're diatomic molecules, and they're turning into water, H2O. If you've seen The Martian, he did this. He blew up, and then he did it again, and it worked. It's the recipe for water. But right now it's unbalanced. We have 2 hydrogens on the left, 2 oxygens on the left, 2 hydrogens on the right, 1 oxygen on the right. So the thing that's out of whack that we already saw is oxygen. We've got 2 oxygens over here on the left-hand side, and we've just got, oh, that's not a highlighter. There we go. We've got 2 oxygens and 1 oxygen. So what we have to do is add some oxygen to the right-hand side to make it balanced. So you could add an oxygen like that. The thing is, though, oxygen is not a product here. It's not something that's being produced. So we can't just add a random oxygen by itself over there. What you have to do is add the entire compound as it is written. So we would have to add the whole H2O molecule there. Cool. Now we've got 2 oxygens on the left-hand side and 2 oxygens on the right-hand side. Easy peasy lemon squeezy. However, that did throw slightly out of whack our H's. Now we've got 2 H's, 2 hydrogens on the left-hand side. We've got 2 4 on the right-hand side. Oh no. What can we do? Well, we'll have to add some more hydrogen over here on the left. Now we've got 4 hydrogens right there, 4 right there. Oxygens are still 2 and 2, so we're all good. We're all balanced. Now what you can do with this is, instead of writing it this way, or after you write it this way, the way we actually write it as an equation is we place coefficients, this word coefficients like in math, and they go in front of elements and compounds to change the number of atoms that you need. And basically, it's just a big number you put in front in these little blanks. The number, the coefficient, is the number of units of that compound that you used. So right here we used 2 H2s. We didn't add any O2, so we just have the 1. And we had to add on another water for a total of 2 waters, 2 H2Os. So the total balanced formula would look like 2H2 plus, if it's a 1, you can leave it out, O2 yields 2 H2O. That is a balanced chemical equation. Now it's up to you to go do some examples over in your notebook. So I can't do it here because the program I'm using, but over in the gray space, which is on the left side of the slide number 7, I think, in your notebook, you've got stacks of boxes for each of these elements. So what you're going to do is click and drag those over, line them up down here in the space under each element till you reach the appropriate number for each thing. And once you've figured it out, you'll count it, or count the number of boxes you used, write it as a coefficient, because these are little text boxes that you can type in. Write it as a coefficient for each of these things until you've got them all balanced. You've got a bunch of chemical equations. So I'll give you a few minutes to do that. I'll pause the video, write in the answers, and you'll tell me, or you'll see if you get them right in the end. All right, and there you have it. Those are the answers all done out. Hopefully you got those right. If you did not, as always, please get help, rewind the video, try to figure it out. Ask your teacher, come to office hours, whatever you need to do to get help, do that. All right, there should also be a conservation of mass manipulative to finish today, or maybe tomorrow, depending on your teacher. There is a brief instructional video that's included in the slides, and the instructions are there as well. So hop on that, get to work, and have a good day.